Hey Fiona, can you help me with something?
Hello, Jamal. Sure, what is it?
Can you help me with my homework? Our teacher gave us a task. She wants us to know about the history of the periodic table.
I think I can help you with that. Let's go and explore its history.
Before we discuss about its historical significance, let's start by defining the periodic table.
Oh, I know what a periodic table is. A periodic table is a tabular arrangement of chemical elements organized by their atomic number, electron configuration, and recurring chemical properties. It contains a row called periods and columns called group of families. Elements within the same group often share similar chemical behavior due to their similar electronic structures, while elements across periods typically exhibit a gradual change in properties. Dmitry Mendeleev is created with the initial development of the periodic table, arranging elements based on their atomic masses and leaving gaps for undiscovered elements which were later filled as new elements were discovered. The periodic table serves as a fundamental tool in chemistry, providing a systematic way to understand and predict the behavior and properties of elements and their compounds.
Now that we know what a periodic table is, let's move on to its history.
Antoine Lavoisier, often hailed as the father of modern chemistry, made significant contributions to the understanding of chemical elements. Although his direct involvement in the development of the periodic table was limited, Lavoisier's groundbreaking work in the late 18th century laid the foundation for modern chemistry by establishing the law of conservation of mass and identifying oxygen as a key element in the combustion reactions. His meticulous experiments and precise measurements revolutionized the field, leading to the conceptualization of elements as fundamental building blocks of matter.
Lavoisier's work focused more on chemical reactions and compositions of compounds rather than the systematic organization of elements. His discoveries paved the way for future chemists to explore the periodicity of elements. His emphasis on accurate measurement and systematic experimentation had laid the groundwork for Dmitry Mendeleev and other scientists to develop the periodic table in the mid-19th century. By establishing the importance of elements in chemical reactions and understanding their properties, Lavoisier indirectly contributed to the classification and organization of elements in the periodic table.
In essence, Antoine Lavoisier's contribution to chemistry, including his insights into the nature of elements and chemical reactions, played a crucial role in shaping the scientific landscape that led to the development of the periodic table. While he didn't directly participate in its creation, his foundational work provided the framework upon which subsequent scientists built, ultimately leading to the systematic arrangement of elements based on their properties and atomic structure.
Hey Maurice,
Oh, hello there, Jamal.
do you know about Johann Wolfgang Weber-Reiner? I heard that he also contributed to the development of the periodic table.
Oh, in 1829, Johann Wolfgang Weber-Reiner, a German scientist, found some groups of three elements which showed similar properties.
These groups were called the Weber-Reiner's triads. Triads were based on both physical as well as chemical properties. Here, we can observe that the middle element's atomic mass is roughly equal to the average of the atomic masses of the other two elements. Due to the primitive nature of this classification, Weber-Reiner was only able to identify a small number of triads among the known elements. Other triads did not obey the rule. Hence, the system of triads failed.
Thank you, Maurice.
You're welcome, Jamal. Now I'll get going.
Alright.
Hey Jamal, I found some new information about the periodic table. In 1862, the French geologist Alexandre-Émile Descartes published a paper describing a classification of the elements. Descartes' telluric screw, as he called it. He placed the elements in order of atomic weight in a spiral pattern around the cylinder, Descartes' periodic system. John Newlands was a pioneering chemist whose significant contribution to the periodic table came in the form of his law of octaves. In 1864, he arranged the known elements into a table where elements with similar properties appeared at regular intervals, much like the octaves in music. This concept suggested a periodic recurrence of properties, with every eighth element sharing similarities. Newland's law of octaves laid the groundwork for later developments in the organization of elements.
Despite facing initial skepticism and criticism from the scientific community, Newland's work foreshadowed the periodic law proposed by Dmitry Mendeleev a few years later. Mendeleev's periodic table gained wider acceptance due to its more comprehensive organization of elements, but Newland's contribution is crucial in recognizing the repeating patterns of elemental properties. His insights into the periodicity of elements paved the way for the modern periodic table, which remains one of the most fundamental tools in chemistry today.
John Newland's legacy extends beyond his love of octaves. He was a trailblazer in the systematic classification of elements, demonstrating the predictive power of organizing elements based on their properties. Although his specific arrangement was eventually refined and expanded upon, his pioneering efforts marked a crucial step in the development of our understanding of the periodic nature of elements, shaping the way we teach and study chemistry to this day.
Dmitry Mendeleev in Russia and Lothar Meyer in Germany independently recognized that there was a periodic relationship among the properties of the elements known at the time. Both published tables with elements according to increasing atomic mass.
But Mendeleev went on a step further than Mayer. He used this table to predict the existence of elements that would have the properties similar to aluminum and silicon, but were yet unknown. The discoveries of gallium and germanium provided great support for Mendeleev's work. Although Mendeleev and Mayer had a long dispute over priority, Mendeleev's contributions to the development of the periodic table are now more widely recognized.
Henry Moseley made a groundbreaking contribution to the periodic table through his work on atomic numbers. Prior to Moseley's research, elements were primarily classified based on its atomic mass, which led to inconsistencies and inaccuracies. Moseley's experiments with X-ray spectroscopy revealed that each element's atomic number, representing the number of protons in its nucleus, determined its unique identity. This insight provided a more robust framework for organizing elements and laid the foundation for the modern periodic table.
Moseley's discovery of the relationship between an element's atomic number and its position in the periodic table revolutionized chemistry. By arranging elements in order of increasing atomic number rather than atomic mass, Moseley clarified many inconsistencies in the periodic table. This reorganization not only resolved ambiguities, but also enabled scientists to predict the properties of undiscovered elements with remarkable accuracy, leading to the discovery of new elements and the refinement of existing ones.
Moseley's work had profound implications for the fields of chemistry and physics, fundamentally changing how scientists understanding the structure of matter. His systematic approach to organizing elements based on their atomic numbers provided a solid framework to future research and laid the groundwork for advancements in nuclear physics and chemistry. Henry Moseley's contribution to the periodic table remain a cornerstone of modern science, ensuring his legacy as one of the most influential figures in the history of chemistry.
So in summary, Antoine Lavoisier laid the foundation for modern chemistry by establishing the law of conservation of mass and identifying oxygen as a key element of combustion reactions. Johann Wolfgang de Vernier placed various groups of three elements called triads. Tandre-Émile Bigayr, Decan-Curtis, made a Decan-Curtis telluric screw. John Newland suggested that when elements were arranged by increasing atomic mass, every 8 elements exhibited similar properties. In Henry Moseley, elements were primarily classified based on their atomic masses, which led to inconsistencies and inaccuracies. Thank you for your help, Fiona. Send my thanks to Maureen.
Exactly, Jamal. I certainly conclude that you have learned something. And sure, I'll send your things to Maurice. And most of all, I hope that you all have learned about the history of the periodic table.
Thanks to Maurice.
Exactly, Jamal. I'm sure you have certainly
Thank you for your help, Fiona.
Dili na ka mag-cut kay magtuloy.
publish a paper.
Anto, 3, go.
Thank you, Maurice.
Combination. Wow, amazing.
Ikatra.
Think of chemical elements. Oh, si Maurice.
What did your guest in class?
She wants